In question 49, you're going to have a look at a comparison of two methodologies, the straight line depreciation method and the reducing balance. Now 15% of 20,000 for the straight line figure, that's equal to $3,000. So straight away, I can quickly enter the data. The value at the start, 20,000. Subtract 1,700. I'll just pause the tape and complete that. So you can see at the end of 6 years, the items are worth $2,000. Now it does say to check each table using the formula. So if I did that, so they do indeed match. Now when we're dealing with reducing balance depreciation, that's 25% of the value at the start of the year is the depreciation. So you've got a lot of fiddly little calculations to do here. So 15,000, the depreciation the next year is going to be less. Works out being 3,750. I'll just pause the tape. You might like to choose to work through the rest of that as well. So the table at the end of 6 years gives us $3,559.57. Now when I put that into the calculator, it ends up being, fortunately, the same value. Now, how long does it take for the straight line balance to show a lower value than the reducing one? So it's a little bit harder to see because you've got to check through here. You can see the reducing balance is lower, for the first 5 years. It's in the 6th year where the straight line depreciation gives a lower value. Or end, I should put. Now, general equations for finding the value of the vehicle after n years for each method. Now, in order to do that, we've got to go back to the whole business of what the equations look like. So for the straight line case, V is equal to minus dn plus c. In this case, V is going to be 20,000 minus 3,000 lots of n. The 3,000 is the D, the n is the unknown. For the reducing balance, the amount, if you like, or V is equal to D, P, or cost, if you like, 1 minus I to the n. And in this case, the value is going to equal 20,000 times 1 minus 0.25 to the n. So there are your two equations. Now the next step, you're asked to actually put those into your calculator. Now that's going to work a little differently to what we've done before. So on the calculator, I go to the home screen or the menu. I'm actually going to enter a graph and table scenario. So I'm going to enter these two as new equations. I'll just clear off the rubbish to begin with. And that's going to be 20,000 minus 3,000. Look, it's easy to work with x's in these cases. And the second scenario for the reducing balance is to be red, 20,000 times 0.75, and we'll raise that to the power of x. Now, having done that, it's extremely unlikely whether you're going to have a nice graph system lined up for that. So what we do, we're going to change the view window. Now, clearly, I want to be able to see below the axis, so I might make that negative 3,000. It just helps me see things. My maximum, Now the initial value of the item is 20,000. I'll go up to 25,000 and I'll say give it scale values of 5,000. Don't touch the dot business. The Y minimum, we go between 0 and 6 years. I'll put in 7 and I'll just scroll that down. It looks okay. And I'll select the graphs. That would be pretty handy. Press the graph function. And with some luck, you should be able to see your two graphs pretty readily. I put them around the wrong way, haven't I? Trap for young players or old players. So I'm actually going to have to fix that up. I'll make that value maximum of 6 and the minimum of 0. And switch them around. We'll make that negative 3,000. And we'll go up to 30,000. And I'll put it in scale of 5,000. That's better. So I'll just move that along so you can see the red line, the reducing balance, plummets quite early, then levels out. And the break-even point, if I quickly go via analysis, GSolve, I want to find the intersection. There's two of them where they first meet, and I'll just tab along that, and I can quickly find the second value of 5.15 years at 4,542. So in other words, the values will be the same at that figure.